Hello there, welcome to the 13th part of learning everything we can learn from VisionOS Documentation. Here, we're going to look at the article, Tracking Specific Points in World Space, another ARKit article. This is about retrieving the position and orientation of anchors that we have stored in our ARKit using the World Tracking Provider. Okay, let's use world anchors along with an ARKit session, world tracking provider, to track points of interest in the world over time. As a person moves while wearing the device and across device usage sessions. For example, someone might place a 3D object in a specific position on their desk and expect it to come back the next time they use the device. ARKit keeps track of a unique identifier for each world anchor your app creates and automatically places those anchors back in the space when the person returns to your app in the same location. A world tracking provider also provides the position of the device the person is wearing. Here, a quick demo of a teapot on a table. Now, we're going to start an ARKit session with world tracking. By using an ARKit session configured with the world tracking to start receiving updates on world anchors at your app places. The following shows updates to world anchors your app previously registered using the add anchor method. Here we have a session. Here's our provider. Next, we run our session with this particular provider, and we are getting all sorts of asynchronous updates from our world tracking provider to update the information about the world anchors we have previously registered, which we'll learn in the next section of this article. Okay, before that, let's read this important part of this article. If a person repositions the current space, for example, by holding down the digital crown, world anchor updates begin updating their position relative to the new world origin. For example, a world anchor placed on a table still reports information about the table's position, but those positions are relative to the updated world origin. Okay, so we get new information. Create and add world anchors. You can create world anchors for any point of interest your app world coordinate system once you have started a world tracking ARKit session. For example, you might track that a person's placed an item at a particular offset from a table in their space. Let anchor equals world anchor, origin from anchor transform, display.origin from anchor transform plus offset, try await world info dot add anchor anchor. Once you add a world anchor to your app's tracking provider using add anchor method and the add updates sequence in anchor updates sequence in the current section and future runs of the app provide updates to the current position of that new world anchor. One thing I find pretty interesting is that we pulled a display origin from anchor transform to be our world anchor position. That we don't know exactly which desk we just pulled it from. It just assumes that we find some sort of desk and chooses a particular position for that desk and pulls it in for us. So that's pretty interesting. Next, persist world anchors across sessions. The only information ARKit persists about the world anchor in your app is their UUID, a world anchor instance ID property, and pose in a particular space. This is probably XYZ coordinates. It's your app's responsibility to persist additional information, such as the meaning of each anchor. For example, you might save local data about a custom 3D lamp model that a person placed on their desk. So maybe like whether the lamp is on or off in a particular type of lighting color, maybe. As a person moves from town to town and room to room, your app won't receive all of the world anchor updates from each place someone uses your app. Instead, the anchor update sequence only provides world anchors for nearby objects. I think they mean by only your particular room, but I'm not sure in this case. Track the device position in the world. Use the compositor service framework and the world tracking provider class. This is query device anchor timestamp function method to get low latency information about the current and future predicted pose of a person's device in world space. For example, see drawing full immersive content using Metal. This is only required of us if we're using compositor service framework to compose our own scenes, I believe. Let's take a look at this Metal. We're going to create a fully immersive VisionOS using a custom Metal-based rendering engine. We're going to do our own rendering service, which we don't usually do if we're using Reality Kit. So that much is fine for us. With that, we have completed this piece of article. We have learned a little bit. I wish we could learn a little bit more if we had some sample code lying around. Maybe I can see if I can create some sort of code for us, and let's see what we can do. Let's dive into some code. We were able to get this code a little working. Not too well, but it's working. And we have our world tracking provider. We make sure that it's another data provider off of the same protocol. So therefore, it's a data provider, and so we have the is supported off of that protocol and .state off of that protocol. We need to make sure that these things are supported and has been initialized. Along with the hand tracking and scene reconstruction provider, the world tracking provider needs to be initialized in our scene session. And so we have our session here, and we initialize that after we check that the data providers are supported and is ready to run. Here we have the world tracking provider initialized here, along with the scene. Now, once it's all running and everything, we can make a task upon a tap gesture, where we have added a few cubes, and we can mark this as our world anchor. Now, with this world anchor, we can wait for those cubes to move, and it would update its position, and we can make some sort of interaction with the world at this particular point. We can also just say print the new position of the anchor. With that, I think we have gone over a very simple example of this code and see how it kind of works, because this app doesn't truly work. As we recall, this app runs, but for some reason, we cannot place cubes onto the table. All right, with that, let's end the 13th video here, and we'll move on to our 14th video very soon, and we'll be learning about tracking pre-registered images in 3D space. All right, wish you the best. I'll see you in the next one.